Hello everyone, welcome to you all. Now I am going to discuss about mirror formula using concave mirror in terms of virtual image condition. So as I have discussed mirror formula using concave mirror in terms of real image condition. So I'll provide the link below in the description box. You can watch from there. So let's get started. So for our completeness, I have already made a figure alongside. Let us acquire some information regarding our figure. So here we can see an object AB is placed between principal focus and pole of the mirror. So in this condition, concave mirror always forms a virtual image. So which is A dash B dash. We can see here in the figure. So from figure we can write triangle ABC is similar to triangle A dash B dash C. So here we can see these two angles both being 90 degree, they are equal, and this angle is common to both the triangle. So they are similar. So as we know, the ratio of corresponding side of similar triangle are always equal. We can write AB by A dash B dash is equal to CB by CB dash. So let us consider this equation as equation 1. Also we can write triangle MNF is similar triangle A dash B dash F. So here M and F, that means this angle and this angle both being 90 degree, they are equal, and this angle is common to both the triangles, so they are similar to each other. So like above we can write MN by A dash B dash is equal to FN by FB dash. So as we see from the figure, MN is equal to AB, means we can substitute MN as AB. So above equation can be written as AB by A dash B dash is equal to FN by FB dash. If this point N is very close to P, then we can write Fn as Fp. So above equation can be written as AB by A dash B dash is equal to Fp by Fb dash. So let us consider this as equation 2. So from equation 1 and equation 2 we can say that Cb by Cb dash is equal to Fp by Fb dash. So our next aim is to reduce all these terms in terms of FUV, that means focal length, object distance and image distance. So let us do it. Cb can be written as Cp minus Bp. So Cp minus Bp as a whole divided by, here Cb dash can be written as Cp plus Pb dash. Cp plus Pb dash is equal to, let us leave Fp as Fp itself, by here Fb dash can be written as Fp plus Pb dash. Fp plus Pb dash. Now applying Rp sign convention rule, that means real positive. So we can write Cp as twice of focal length, so twice F, minus Bp is our object distance, which can be written as U by Cp twice of focal length, plus Pb dash. Pb dash, this is our image distance and it is virtual, so we have to write it as minus V according to Rp sign convention. So here Fp, it is our focal length, F divided by Fp, it is our focal length, plus Pb dash, it is our image distance, so we have to write minus V since it is our virtual condition. So here this equation can be written as twice F minus U divided by twice F minus V is equal to F divided by F minus V. So now we have to do some mathematical calculation over here. So let us cross multiply them. We get twice F square minus twice Fv minus Uf plus Uv is equal to twice F square minus Fv. Since these two terms are equal, they cancel out each other. So when we bring minus Fb to LHS, minus twice Fb plus Fb, we get minus Fv minus Uf plus Uv is equal to 0. So here dividing both sides by FUV, we get minus 1 by U minus 1 by V plus 1 by F is equal to 0. So this can be written as 1 by F is equal to 1 by U plus 1 by V. So this is our required mirror formula for concave mirror in terms of virtual image condition. So thank you.